looking at lecture 4, Systems of Linear Equations. You'll find this on page 72. Consider the graphs of two straight lines. What are the possibilities with respect to their positions? Right? We could get the straight lines intersecting at one point only. So intersect at one point only. So in this case, you have a unique solution. The other possibility is that we could have two distinct parallel lines. So parallel lines distinct, and in such a case we have no solution. We could also get a case where the straight lines coincide. Right? In other words, it's the same straight line. Right? The defining equations can be reduced to a particular form, to the same form. So in this case, you are going to get infinitely many solutions. Okay, we're going to look at a few cases where we have linear systems of equations and we want to solve them. These are types of equations you've come across at school, equations in linear systems, linear equations in two unknowns. Now, to solve simultaneous equations, you could make y the subject of each equation and then equate the y, do the replacements. You'll get something in terms of x equal to something else in terms of x. You can find x and then go and find y, right? If possible. Right? The other thing is we could reduce, or we could eliminate one of the unknowns and then find the remaining unknown and then go back and find the unknown that you eliminated. So let's call this equation 1, this equation 2. I'm going to follow that procedure. So if I want to eliminate y, then I need to take equation 1, right, and multiply by 2. So that's going to give me 4x minus 2y is equal to 2. Then writing down equation 2, we'll call this one, this equation 3, and this one equation 4. Now, if we add equation 3 to equation 4, then we get 10x is equal to 14. Therefore, your x is equal to 14 divided by 10, which is equal to 7 divided by 5. Substituting in equation 1 gives it's going to be 2 multiplied by 7 over 5 minus y is equal to 1, from which we can therefore find y. I'm taking y onto the right hand side, so y is equal to 14 over 5 minus 1, and that gives me 9 over 5. So therefore your x is equal to 7 over 5 and y is equal to 9 over 5. And that is our solution. Looking at 1.2, so we've got the system of linear equations we want to solve. So I'll call the first one equation 1, the second equation equation 2, and if I multiply, if I try to eliminate x or y, I need to multiply by 3. Suppose you want to eliminate x. So that gives me 6x minus 3y is equal to 3. All right, this is equation 3. And if I write equation 2 below it, if I want to eliminate x, so it's equation 3 minus equation 2. For the left hand side, remember when you're subtracting, what you're subtracting, you'll have to change the signs and then add. So it's going to give me 0 for the left hand side is equal to -9, and we know that this is impossible. 0 is not equal to -9. So the conclusion here is therefore there is no solution. Right? If we go back to the equations that we are given, take the first equation, you can see that you'll get y is equal to negative 2x minus 1. And from the second equation, you'll get 3y is equal to 6x. Sorry, here it should be the y for the first equation is y is equal to 2x minus 1. So from the second equation, it's 3y is equal to 6x minus 12. If I divide by 3, that implies that y is equal to 2x minus 4. So you can see from the gradients of those lines, the gradient is 2, so that the lines must be parallel, and you can also see that the y-intercepts are different. So you're going to get two distinct parallel lines, so there is no solution. We now move on to 1.3. Right, it's your first equation, second equation. Note that the variables are one below the other and the constants are on the right hand side. So we can proceed. I can take equation 1 and multiply by 3. So that gives me 6x minus 3y is equal to 3. Call this equation 3. And I can write the second equation down as it is. And if you look at the equivalent system, right, this one, we have the same equations, right? So it means that there's one straight line really, and for the two equations, the lines really coincide. So therefore, lines coincide. There are infinitely many solutions. Given by the set of all ordered pairs in the form x and y such that, right, we can write down the condition given by, say, the first equation. So that's 2x minus y is equal to 1. Okay, we will stop over here.